Hello everyone, welcome to this video series on C programming. This is the first video of the series. In this I'll be explaining how a software runs on a computer. So say for example, I have a software. So what is a software? A software is a set of instructions with some data. Okay. It may or may not have data, but it definitely have instructions. Where is the software stored? Software is stored on disk. Okay. As all the other files are also stored on the disk only. All files are stored on disk, and there will be other files as well, such as some data files. Okay, all files have different formats, different type of data, different utilities. Your mp3 files, video files. A software will, if you are using a Windows operating system, the software will be .exe file. Okay, the software is just another file like all the files, but the bits written inside the software work as an instruction of what to perform, and these files might be data files, means this is the data which is to be processed. Okay, so this is my disk. Okay, and disks are having large sizes, that means large storage capacities, say for example 1 terabyte or 512 gigabytes. Okay, how do disk store a data is like there is a magnetic platter. Okay, it is a magnetic disk. That means it has two surfaces. One is like this surface, the upper one, and one surface can be viewed from the bottom side. Both surfaces have the capability of reading and writing. So reading and writing is done by the read and write heads. Okay, these heads can read up and down of this platter. This platter continuously rotates with very high speed, 7200 rotations per minute, 5800 rotations per minute. Okay, here data can be read in the form of, like, it's a magnet. The magnet will have two poles, north pole and south pole. If north pole is up, we assume that to be bit 1, and if south is up, we assume that to be 0. Okay, if south pole is up, then we assume it is 0. This is the convention. Similarly, if I want to write a data, then also I'll have to flip these bits in accordance to my data. Okay, this is what happens inside magnetic media of storage, such as hard disks. Okay, so now we have our software. Okay, and the software will have some instructions for the processor. So let us say here is our processor. The processor wants to execute instructions which are stored in this software. So it needs these instructions here, but it cannot take these instructions from here and execute, because the size here, you see, it's 1 terabyte of data. So for 1 terabyte of data, to address each byte, how many address lines will I need? Okay, so address lines will be same as that number of bits. So how many bytes are there? 1 terabyte is there, the data, terabyte. If, say for example, I am addressing every byte, it is byte addressable space, then it will take 40 lines. Okay, like these many bits will be needed to address this whole memory space. So that is a huge data. That is first point. Size is too huge, so the bus will be needed. A very thick bus or 40 line bus will be needed for data transportation from hard disk. Second is speed. Okay, to overcome both of these parameters, this is size of the bus and second is read write speed of the disk. To overcome this hurdle, there's another media which is known as RAM. Okay, now RAM is generally smaller in size than the disk. So RAMs are typically say 16 gigs, 16 GB, or might be 32 GB, 64 GB, and they can go down to 2 GB in the factors of 2. Okay, 2, 4, 8. gigabytes. Okay, this is the trend of RAM. Say for example we have a 16 gigabyte RAM. Okay, so how many address lines will be needed? 16 into giga. Okay, these many bytes I need to address. 16 is 2 raised to the power 4 times giga is 2 raised to the power 30. So it will need only 34, and here it was needing 40 lines. So here the data bus length is also reduced. So size of bus is less needed. Size of bus is reduced, and speed is increased. Speed is increased because RAM is implemented using resistors and capacitors. Okay, so if a capacitor is charged, okay, means Q is not equal to 0. This implies it is 1. And if a capacitor is equal to charged, this implies it is 0. So writing to a RAM is way more faster than writing on a hard disk, and similar is the case for reading. So now let's come to the point how the software execution occurs. Okay, so now what will happen is, this is my processor. Okay, so now my software will get loaded to the RAM, and the instructions will come to CPU all the way from RAM, and the results will come back to RAM. There's also a smaller storage unit here. Let us not go into it now, but when we will study about C programming, then we will talk about that also. They are called registers. They are way smaller than RAM. There's a limited number of registers. They are given by the manufacturer, and they have fixed size. They are way more faster than the RAM because they are inbuilt into the processor. Okay, so software got loaded on the RAM, instructions went to CPU did some execution. Now it may require some data on which those instructions are to be executed. The data might be in one of the files on hard disk itself, or the data might be supplied by the user who is running the software. Okay, so to see what's going on, we have our monitor as one of the output devices. Okay, and to provide the inputs, we have a keyboard. Okay, and we may have a mouse. Okay, and we may have some other things, like we may have a scanner. Okay, that sort of input devices might also be there. Okay, so these are input devices, so they will give the input. Okay, and monitor is an output device, so output will be displayed on the screen. May it be graphical or may it be textual. Okay, you might be working with command line interface, which is textual, or maybe a graphical user interface, which is graphical. Okay, like you can click and all. The data might also be needed to stored. Okay, like we got the output, we might be willing to store that output, so that storage happens on disk again. Okay, after processing, the data will be stored on the disk. Why? Because I told you it is an electronic media, right? So as soon as power supply goes out, this will set to 0. Okay, because it has capacitors, and capacitor will hold a charge only when there is a voltage. C is equal to Q by V. Okay, capacitance is charge held per unit of voltage. Okay, if voltage goes to 0, so we can also say, right, CV is equal to Q. C is a constant. If voltage goes to 0, the charge held will be 0. So all of the data written on RAM will vanish out. Everything will become 0. That is why if we want something to be permanently stored, we will send it to disk. And here we have like poles, north and south. Once we flip them, they will stay the way we kept them until we do not again come and change them. So this is how the software execution occurs on a PC. In the next video, we'll see how to write the software. Why do we go for C programming? How C programming came into existence, a little bit of history, usage and powers. That's it for this video. Please like, share, and subscribe. Peace.